L'hypocrisie dans la politique, ce n'est pas bon, nous n'en voulons pas. Démagogie dans la politique, ce n'est pas bon, nous n'en voulons pas. La dictature dans la politique, ce n'est pas bon,
Okay, this is the second half of the video we started last day on 1.2 radical operations. We're going to finish it off today, and the whole lesson is going to be looking at taking the square root of a power. And unfortunately, as I told you last day, this is a difficult lesson. Some people claim this is the most confusing part of the whole course. That's bad news. The good news, though, is it's a very small part of the course. It doesn't carry on throughout the course. If you can get this, it's great. It shows you have good number sense when it comes to radicals and powers. If you don't get it, well, there's plenty of other things to worry about that you'll be able to get in this course. So give it a good shot, and I think you'll be surprised how much you can understand here. So before we're going to go any further, I want you to take a look at this, the square root of 36, and this, the cube root of 8. And you know the answers to these. The square root of 36 is equal to 6. And the reason for that is because you could rewrite 36 as 6 times 6. And since what you're asking with the square root is what's a number that multiplies by itself to get 36, you've shown right here the number is 6. So another way of thinking of it is, because there's a little 2 here as the index, if you can get a pair, you're allowed to take it out. And so you get the 1, 6 coming out. In this case, you wouldn't be looking for a pair, you'd be looking for a group of 3. And there is a group of 3. Because 8 can be written as 2 times 2 times 2. And since it's an index of 3, you need to have 3. We do have 3, so out comes the 2. I know that it's probably more confusing than it needs to be, but I'm trying to make this point that if there's a little 2 out here, you need to have pairs in order to find a square root of it. Because we're going to do a lot of that in here. Okay, so for all these questions, it's square root, square root, square root, square root. And that's an even, right? If it's a 2 right here, that's an even number. So what do you know about x to the n then, if it's an even index? This is very important. If this is a square root, if it's an even index, then x to the n must be positive. You have to have a positive amount inside a square root sign. You cannot take the square root of a negative amount. We did that last day, right? You can take the square root of 25, it equals 5, but you cannot take the square root of negative 25. It's no solution. So this amount inside has to be positive. Okay, if n is even, if the exponent is even, that's great, because x is n is always going to be positive in that case. We said x of n must be positive, and if n is even, it always will be positive, right? Whether x is positive or negative, if n is even, you're going to end up with a positive amount. So for example, if you wanted to find the square root of 2 to the 4th power, in this case n is even, it's 4, 2 to the 4th power equals 16, and the square root of 16 is 4, so that works out very nicely. But what about if it was the square root of negative 2 to the 4th power? This makes me nervous having this negative sign in here, but the nice thing about having n as an even number, 4, is that when you multiply negative 2 times negative 2 times negative 2 times negative 2, you end up with positive 16. It's still a positive amount, and you can do that. It equals 4. So having n as an even amount, is an even number, is awesome, because x of n is always positive, and we already said x of n must be positive if you're doing square roots. Okay, if n is odd, you need to be careful, because x of n could be negative, and it's not allowed to be negative. X of n must be positive. So let's take an example there. What if we had the square root of 4 cubed? Well, we can do 4 cubed. 4 cubed is 64, and the square root of 64 is 8. Oh, so it works. It's great. N is odd, it's 3, and it worked. But be careful. What if it was negative 4 cubed? So negative 4 all cubed equals negative 4 times negative 4 times negative 4 equals negative 64. And now I'm looking for the square root of negative 64. You can't take the square root of a negative number. So this is a no solution. It didn't work. Okay, so this is why you have to be careful if n is odd. Okay, so let's start looking at the questions down the side here. So the first one says square root of x squared. And just as I did up here with writing the 6 times 6 and the 2 times 2 times 2, you could rewrite this. You could rewrite x squared as x times x. And we have a pair, and that's good because this is a square root. There's a little 2 out there. And remember we said if you have a square root and you can get a pair inside, you're able to get an answer. So in this case, we have a square root, we have a pair, so we have an answer. The answer is x. Great, done, finished, right? No. Why is it not finished? Because the answer is not x. The answer is the absolute value of x. Uh-oh, this is what makes this lesson so difficult. Why would it be the absolute value of x? Okay, let's take a look at this. If, for example, we were looking at this, the square root of 5 squared. So this is of that form, right? Where x is 5 and squared is squared. And so the only thing I've done is I made x 5. If we do that, then I could do the 5 squared first, so I get the square root of 25, and the square root of 25 is 5. Okay, good. What if it was negative 5 in here? Should still work because we have an even, n is even, and it says that's great. So let's see. Negative 5 squared is positive 25, and you take the square root of that and you get 5. What's the problem? Why do we have to do this absolute value? Because look at what we started with here. Here, x, the thing that we replaced this x with was with a 5. X was 5, and the answer was 5. So x was 5, and we got the answer is 5. This looks good. But in this one, x was negative 5. That's what we plugged in, negative 5 into the x, and our answer was 5. Uh-oh, if we just said x here, it would mean the answer was actually negative 5, because that's what we replaced x with in this second question. So this is why we have to put the absolute value signs, to show that you can't take the square root of something and get a negative number, right? This is what I talked about way back here. When I ask you for the square root of 36, the answer is 6, not negative 6. So if I'm asking for the square root of some amount, whatever that amount is, you have to make sure it's a positive amount, and that's why we put the absolute values on. Ooh, tough, eh? Well, it gets tougher. Okay, the square root of x cubed. So square root of x cubed, so I can write that as x times x times x. Okay, in this case, our n is odd. N is 3, it's odd, we have to be careful. X of n could be negative. So look at the x here, what would make it negative in here? What kind of number? Well, if x was positive, it would be great. A positive times a positive times a positive is fantastic. What if x was 0? That'd be okay. 0 times 0 times 0 is 0, and the square root is 0, 0, that's okay. But if x was negative, it wouldn't work, because you end up with a negative amount in here, and you couldn't do it. So what you have to do is you have to make a restriction. And what I mean by that is you're restricting the domain. You're restricting which numbers x is allowed to be. X can't be any number here, because all the negative ones won't work. So what you have to say is x is greater than or equal to 0. It can be 0, it can be bigger than 0, but it can't be negative, it can't be less than 0. So this is actually going to become part of our answer. Okay, so let's go back to this. We'll talk about restriction again in a second. We've written x times x times x, and we're looking for a pair because there's a little 2 out here, and we've definitely got a pair. There's our pair. So one of those x's comes out, and our answer is, there's our x that came out. There's still one left inside. So the answer is x root x, and our restriction was x is greater than or equal to 0. Now, some of you are probably saying, don't forget the absolute value signs. Do I need to put absolute value signs on this? No, I don't. Why do I not need to put absolute value signs on this? The reason I don't need to put absolute value signs is because I've already restricted it. I've already said that x is greater than or equal to 0. So it's impossible that suddenly I have a negative number here, because I've already said that x has to be greater than or equal to 0. So I'm going to write that down. No absolute value signs, because we already restricted x. We already said that x can't be negative, so we're done. Okay, here's one more to blow your mind, and then I think the hardest ones are over. Not that they get any easier. So the square root of x to the fourth means x times x times x times x. Do we need a restriction in this one? No, we don't. How come? Because this is an even number. If n is even, great. The x of n part, the power inside, is always going to be positive, and that's what we want. So no problem, no restriction. So now let's pair up find our pairs here. So there's one pair, there's a second pair. So what we have coming out is one x and another x. We end up with x squared. Do we have anything left inside? No, there's nothing left inside. Okay, do we put absolute value signs on this? No, we don't put absolute value signs again. Why? Why are we putting no absolute value signs this time? Because whether x is positive or negative in this original expression, whether x is positive or negative, if you get the final answer as x squared, then once you square it, it's going to be positive. Okay, let's just say for a second that x is negative 2. So we have negative 2 to the fourth power. That equals negative 2 times negative 2 times negative 2 times negative 2 equals positive 16, and the square root of positive 16 is 4. And we've said that that has to be equal to x squared. So at first you might say, no, the original answer was negative. But look, negative 2 squared equals positive 4. It worked. So the reason you do not put absolute value signs on this one is because the answer will always be positive once you square it. If it's raised to an even exponent, it's always going to end up being a positive answer, and that's what you need to have when you take the square root. It has to be a positive answer. So no absolute value, because whether x is positive or negative, x squared is always positive. This is really hard, isn't it? I love it. Okay, let's keep going. X to the fifth. So we're taking the square root of x times x times x times x times x. Do we need a restriction? Yes, we do need a restriction because this is an odd exponent. So what part of our answer is going to be that x has to be greater than or equal to 0. That's how we have to restrict it. So let's look for our pairs here. There's one and there's another one. So those can come out. One x comes out, another x comes out. So I end up with x squared, and then we still have the square root of 1x that's left over. And then we add on this restriction. It'd be nice if I could just slide that over. Yes, like that. So do I need to put absolute values on this? No, for the same reason as right here. If it's x squared, then regardless of whether x is positive or negative, once you square it, you're back to a positive number. So that's fine. Alright, x to the sixth. So the square root of x times x times x times x times x times x. By the way, you don't need to write this like I'm doing here. I'm just doing this to help you picture it. So do we need to write a restriction here? No, because it's an even exponent. So it's definitely going to be positive inside. So we'll get our pairs. 1, 2, 3 pairs. Nothing left over. So all that comes out is x cubed. Do we need absolute value signs here? Yes, you do. What if x was negative here? That would be okay, because when you raise it to the 6th power it becomes positive. But if you didn't put absolute value signs in here, then when you raise a negative to a 3rd power, you'd have a negative answer, and you can't have a negative number coming out of a square root. You need absolute values. You could write it like that, or you could write it like that. Okay, next one, x to the 7th. 7 of these. 1, 2, 3, 4, 5, 6, 7. Do we need a restriction? Yes, we do, because it's an odd exponent, and so this middle part has to be positive, so you can't have a negative x there. Okay, we do our pairs. 1, 2, 3. So we have x cubed, and we still have 1 left over. And do we need absolute value signs? No. Why not? We already restricted it. If you already did restrictions, you don't need to put absolute value signs. It's overkill. Okay, next one. 8 x's. 1, 2, 3, 4, 5, 6, 7, 8. Do we need a restriction? No, we don't, because it's an even exponent. We get our pairs, and we'll have 4 pairs. There'll be nothing left over, so we only have x to the 4th out here. Do we need to put absolute value signs? No, because the answer is raised to an even exponent, and when you raise something to an even exponent, it's always going to be positive. So we're down to 3 to go. Just the same sort of thing. You just got to think of it twice. So x cubed is x times x times x, and y squared is y times y. So let's look at the x's first. Do we need to restrict this? Yes, we do, because this is an odd exponent. So part of our answer is going to be that x is greater than or equals 0. Do we need to restrict the y's? No, because that's an even exponent, and that always will be positive. Okay, let's get our pairs. There's a pair, and there's a pair. So we have an x coming out, and a y coming out, and we still have an x inside, and then we have our restriction. Do we need to put absolute value signs on the x? No. How come? Because we already restricted it. Do we need to put absolute value signs on the y? Yes, we do, because we said here that y could be positive or negative because when you square it, but you can't have a negative come out here as an answer, so you have to put absolute value signs around it like that. Okay, I'm hoping you're starting to get kind of a sense of what's going on. It's not a complete disaster, but I do get that this is very difficult. Yes, people complain about this to me every year. Okay, do we need any restrictions? No, these are both even exponents, no restrictions. So we'll get our pairs, and I think they pair up perfectly, so there'll be nothing left inside. And what we'll have coming out is 2 x's, x squared, and 3 y's. Okay, do we need to put absolute value signs on the x's? No, because it's raised to an even exponent, so it's definitely going to be a positive amount. Do we need to put absolute value signs on the y's? Yes, because it's raised to an odd exponent, and if y is negative here, that's okay, because a negative to the 6th power is going to be positive, but you can't have a negative answer coming out here. So you have to put absolute value signs there, or I suppose you could put x squared, absolute value of y cubed. But the first one seems preferable to me. Last one, thank goodness, right? So x times y times y times y times y, 5, 6, 7, I hope. So do we need restriction? We do. We need a restriction on the y. So y is greater than or equal to 0 because there's an odd exponent. Don't need restriction on the x because it's an even exponent. Okay, let's do our pairs. There's a pair of x's, 1 pair of y's, 2 pairs of y's, 3 pairs of y's. So we have x, y cubed, and then still inside we have a y followed by a restriction. Do we need absolute values on the x? Yes, we do, because it could have been a negative here, and we can't have a negative answer. Do we need an absolute value sign on the y? No, because we already did the restriction. Oh wow, we made it, and that is tricky. So, hope you get that, or at least part of it. Hope you get a sense of it, if nothing else. Come ask me questions, struggle away with it, curse and swear a little bit, and rest assured that it's not a huge part of the course. It's a tiny little part. Okay, take
corrompus dans la politique, ce n'est pas bon.